I'm Lenka Kosková-Třísková, and I would like to present you how we are using or how I am using Zephyr in teaching. So just for you to know what and where I teach. I teach for two Czech universities. One of them is located in Liberec, which is close to German and Polish border and the north of Czech Republic, and it's a small university. We have two study programs at our faculty. First one is called Mechatronics, and the second one is called Informatics. And at this university, I have Zephyr in three classes, let's say. The first one is called Smart System Design Labs. It's a one-day workshop which takes regularly every week, and we are prototyping with my students their smart system solutions. So if we do some hardware-based embedded prototyping, I encourage them to use the Zephyr. The second big application of Zephyr, which I have, is in the operating system theory, which is part of the education of those guys for mechatronics as well as for our standard informatics students. The informatics students have this class in second or third year of their study. And in the fourth year at informatics, I teach also something which is called single board computers, which actually it means embedded computing. And I combine there embedded Linux and Zephyr. And I also do teach in Prague at Czech Technical University, the subject which is called Internet of Things. And here again in the labs, I will show you later on, we are moving from originally used Arduino towards Zephyr. And by the way, I also teach at Linux Foundation trainings, which are focused applying embedded Linux and Yocto. So the biggest application which I currently have for the Zephyr in education is the operating system theory. Majority of the students are second year students, and unfortunately last years we have more and more students who started coding just when entered the university with no previous experience in coding. And in parallel, when they have these operating systems, they also started with C, so their knowledge is really limited regarding operating system coding. And also it's again worse and worse year by year that their hardware knowledge actually and their idea how the computer is working is worse and worse and worse. I did this check last year during the first lesson, and I would say that half of the students in the second year had generally no idea what the central processing unit is and what the architecture actually means. So this is what we have. And also, this is a specific in Czech. Regarding the high schools, we have so-called gymnasiums, which are kind of general high schools. And then we have something which we call industry schools. And those industry schools can be really deeply specialized in electronics. So I have it like half to half. Typically, the students who are coming from the general high schools have those limited knowledges, but they can speak languages, for example. And the guys who are coming from the industry high schools typically know how to design PCB boards or have do now much more about the low-level hardware. But again, they mostly have limited experience in coding. And if they have any, it's mostly the application-related stuff or the web design. So the main goal of the class itself is to introduce the general operating system theory, which means the kernel concepts and the protected, unprotected mode, memory protection, kernel threads, system calls, multitasking, scheduling, all of its typical part of any operating system curriculum. And just to the organization in Czech, we have typically teaching for 14 weeks, and we are combining the theoretical lessons, which are given by teacher to all the students who are assigned to the class. So it's mostly up to 100. And then we separate them into the lab exercises, which are typically 3 to 4 for 20 to 25 students. And the lab shall be designed for students to kind of fix what was given in the talk Actually, in Czech, the talks are not mandatory, just the labs are mandatory. So since I started to teach the operating systems like 17 years ago, I wanted to have some nice real example. And originally we were using Linux, but it's too complex for a second year students. You cannot take the kernel, Linux kernel code and start explaining how the kernel is implemented. So we were looking for another example. We did some experiments with FreeRTOS, and finally in 2016 I switched to Embed operating system, mostly because it had nice IDE which could run in browsers, so there was no need to install anything additionally. It was pretty smooth. We got the hardware which was supported by it, etc. But sooner or later, as we came close to 2020, we started to regret this decision because mostly all the samples were not updated. And as the Embed AP started to change, there was that release 2.6, 2.0, 5.0, 6.0. You could see that in a lot of examples and documentation, there were obsolete functions and it started to be unbearable. So in 2020, I decided to switch to something else. And I was very happy that I made this decision because now the Embed is announced the end of life in half a year. So that's why I decided to switch to Zephyr. So I did some original preparation and I want to show you how do we teach it. Actually, why I decided to use Zephyr, contrary to, for example, the FreeRTOS or the other smaller operating systems, mostly because, first of all, it has some kind of POSIX support. So, and we have POSIX as a part of the curriculum explaining the portability in the operating system. So it's a great feature. And several other great features attracted us to Zephyr. It's an open source and very stable one with a very nice and living community. The architecture design is great. And of course, there is a lot of samples available and huge complex documentation which can help students. And also, it's really easy to run the emulations using the QEMU, which is absolutely practical in labs. Again, when you want to demonstrate that the operating system shall be designed and switching the underlying hardware architecture is just switching the configuration parameter. And also, what's also nice that it uses for the build system configuration, the key config and the other stuff, which is similar to the Linux. So for our students in later years, it's easy to adapt also to the Linux build systems. During last 2 years, I was working on the labs. So they are available as an open source. I did most of the development during the beginning of the last year, so you can check it. I have prepared the labs which are demonstrating the working with the threads and synchronization and memory management, and I will continue in this work. I used it for the first time in teaching last winter semester, and it was pretty well accepted by the students. But there is still some more work to come as we need to improve some stuff because it was too complex again for our beginners. The lessons I have learned during the last year teaching, first of all, the documentation is beautiful. If you are senior engineer with some experience in firmware or software development, because it's written by professionals for professionals. But our students were kind of struggling to get the initial answer what the Zephyr really is. So I find out that we need some kind of document, my working title is Zephyr for Squirrels. So you're someone who knows nearly nothing from the operating system theory because you are just starting and you need to get the big picture. How does it all work together? Because actually the getting started guide is not getting started, it's to get it installed, not getting started. So in parallel, I started to write some text for my students, so I hope to have it done during this teaching term, and I will translate it to English. And again, make it available to everyone who can need it. And we will work with my students on it to improve it according to their needs. So as I'm talking to you just now, they shall have the teaching. So they were asked to read the documentation and comment on everything they do not understand. So it's just now happening, I hope. So my experience is that Zephyr is perfect if you want to demonstrate how the threads are working, the operating system, build system, and configurations, and also for the kernel design and scheduling, because again, you can just switch the configuration option to change the scheduling and the types of queues, and these parts of codes are kind of readable for students, so they have the practical example which relates to the theory explained in the talk. And also what's absolutely great feature in Zephyr is the implementation of the driver model, which is not present in other RTOSes, this smart, let's say, complexity as we have in Zephyr, and also the device tree descriptions. What you cannot reach with Zephyr, because a part of the operating system principles is probably also to mention what does the operating system administrator do. Actually, for those tasks Zephyr is not ready. It's better to demonstrate it in Linux, same for the user interfaces, and also the same stuff regarding, let's say, the user-based security stuff like authentication, authorization. Again, this is better to demonstrate in the other operating system. But again, those parts were absolutely perfect. Students were able to do what I have in Git. Let's say they needed like from 90 minutes per one assignment to twice 90 minutes, depending on their skills. And yeah, so this all to the operating system theory. We will for sure keep Zephyr in the education. Just we were last year we were using just the emulation because again I found that it's so hard for students to enter the Zephyr world and to understanding during the labs. So I decided to not to use the hardware because it would make it even harder. So they were using the QEMU emulator, and we will do it the same way this year. And I don't know if I will be able to kind of fasten the time they need, shorten the time they need to adapt or to learn the Zephyr environment and the build system, etc. Maybe we will use some hardware in this training, but actually it's not so much important if you're teaching operating system theory. Okay, in the other classes in Liberec, we are using or I am using this effort to demonstrate how the professional applications are designed. Students mostly have some experience if they are doing this level of prototyping. They have experience in writing firmware in C, or because STM32 platforms are really popular in Czech. They have some experience with the STM Cube and their, let's say, their APIs. But I see Zephyr as a more professional way of doing the stuff. What's nice that it supports all the hardware we need, and I will talk about it later. It's easy to port it to some hardware, even if it's not supported yet. And also, again, the software emulation is great because it helps the students to understand if the problem is in the hardware design or in the software design, to prove that at least they are able to boot something and run something in emulation. It always makes them happy. And also, again, Zephyr itself enables students to focus on the application logic. And again, what's absolutely valuable in this level of application of Zephyr is the documentation and samples and some open solutions based already on Zephyr. Based on my experience from Liberec, I can kind of summarize the different answers I get from different groups of students. As in mechatronics, students really have limited experience with coding, and also they are typically with Zephyr facing first time some kind of professional build system and a way of configuring the software including the libraries, designing the modules, etc. So it seems to be hard to them, and they tend to complain that if I would do it manually as I was used to, it would be much faster. If I would use Arduino, it would be much better because it's so easy in Arduino, etc. So again, what really works when they start to complain is to introduce them to Zephyr Shell, and then the mechatronics guys became to be happy because now they are touching hardware with no coding, and they prove that, let's say, their hardware designs are okay, and they do not need to bother with all of those build systems configurations or complex sources structure. So this is how they first time mostly answer, okay, this seems to be usable and much more practical that compared to the Arduino or the other uh, software stacks I have been used to. And also another kind of attractor to Zephyr is typically if you assign them a task, okay, you have several peripherals, let's say several sensors, and try to read them randomly with different periods independently, and do it by firmware, or please try to implement this to have like 2 threads running in parallel. Try to implement this in your Arduino, then they start to be open to listen, explaining about the threads or synchronization or whatever. So I typically have prepared some examples which are demonstrating, for example, the race condition on displays, and show them, okay, this is what you get if you are not doing it properly. And with Zephyr, you can see this is easy. And again, you are just coding what you need to code, and you don't need to kind of take care of the rest. The informatics students, contrary, because they typically, if they did some coding, they were using Python, they were using some web frameworks, etc. So they are used to complex build systems. So this is not a problem. The problem is the limited hardware knowledge and limited idea in their minds how the computers are working. But again, because they can focus on coding, and when they are starting with Zephyr, they do not need to learn so much about the hardware, or what they also like, that they can cooperate with mechatronics students one-to-one. So the mechatronic guys take care about the device trees and the low-level drivers, and the guys from informatics can design the application logic. And it's nice for them if they are working actually in parallel, because they see that software is a teamwork and everyone is welcome with his knowledge. My general recommendation, if you would like to introduce Zephyr to your labs for students, and if your aim is not to teach Zephyr, but to apply it in teaching as a tool which enables you to teach some principles like embedded software design or the operating system principles, you need to give to the students some time to learn Zephyr. So if you are planning your teaching, you will need to give them like a week or two to get adapted to it before you will start to teach what actually you want to teach. Otherwise, they will get lost, and your teaching will not deliver what you want to deliver. So again, it depends which type of students you have. You will need at least like one 90-minute lesson to introduce the principles, or maybe even more if you have first-year students or really not so experienced students as we sometimes have. So this is to what we have in teaching in Liberec. Actually, which hardware we use, we have plenty of STM32 boards, different versions, and we have also some stuff from Arduino, some stuff from NXP, and some stuff from the M5 stack. I will talk about it regarding to the Prague experience. So, and here is kind of success story how I forced the other university to move from the Arduino to Zephyr actually. So last year I started to teach at the Czech Technical University in Prague at their Faculty of Informatics, which is actually one of the 2 best informatics schools, universities in Czech. And I'm teaching there the subject which is called Internet of Things in third year. And those students are really fast and smart, really good coders. They have excellent knowledge actually already in networking and building the user space applications. And they already passed the operating system theory where they were working in a shell and in the Linux environment. So the original setup was that the guy who designed the training, the course before me, decided to use the M5 stack fire devices with some additional sensors to create the sensor nodes. And so we are using typically for one student's two M5 devices. One is the sensor node communicating via MQTT with the other device, which works as the edge device. So the setup is great to demonstrate all the IoT principles. The M5 stack, the producer supports the Arduino framework for developing the applications, or they also down under the Arduino, actually they are running the free RTOS. Because I agreed to teach it during the summer, just a month before the teaching started, I had no time to move towards something more mature because personally I hate using Arduino in education because it's not a professional way of doing stuff, and we shall prepare the students for, let's say, their professional careers. And especially for the IT students, again, I would like to demonstrate something more mature regarding the safety, security. And I was constantly complaining, saying, okay, we will do it this way, but actually the professional way of doing the stuff is the other one. So that's why I decided when the teaching ended to move to use Zephyr. And because it was not ported to yet to these boards, I decided to do it, and luckily, one really nice student who was just 17 came to our school to do some praxis because he was coming from that industrial type of school, and he needed just 2 weeks to port Zephyr to this device. So at the end of June, we were able to boot Zephyr on the device. And during the summer, with the help of other two students, we added support nearly for all the sensors we have. But because we were not able to convert all the labs from Arduino to Zephyr, we decided, and also I had no time to train the other teachers who are teaching the subjects in the labs in Zephyr. The decision was that we will allow the option to use Zephyr, and I will keep, let's say, in theoretical talks, the Zephyr as an example, but students will have those two choices. They can use because we have a lot of example solutions already written in Arduino, which we did during the last year. So this year I will continue in converting it. And also what I think that for this particular teaching, we also missed that Zephyr for Squirrels introduction. Because in Prague we have just 12 weeks of teaching, and spending, let's say, 1 or 2 weeks introducing just the software framework itself would be hard. So I would like to prepare some for the next year, some introduction for the students to do it at home when they are preparing for the lections. So the summary, Zephyr is absolutely great choice if you are a teacher teaching the embedded systems or any other stuff which is kind of related to the operating system theory, because it's usable, mature enough. But again, as I said, students are different auditorium compared to the professionals, so we need to add to, let's say, the Zephyr official documentation, maybe some kind of really principal way of describing what Zephyr really is and how it works. I think that we can get inspired by from the Yocto documentation, for example, from the embedded Linux. There is a really nice type of material which is called Key Concepts. In parallel with my friend from Zephyr community, we are working on a book which shall describe the Zephyr, but again, the book is dedicated to engineers who are going from the other type of coding into the Zephyr. So it's not the same auditorium as the students, so I hope in parallel to provide at least like 10 pages describing of it because I will need it for my students, so I will make it open later on when I will just clean the English in it. Okay, so that's all from my side regarding Zephyr and teaching, and I'm open to all the questions.
Do you use a book?
Yes, actually, regarding the OS theory books, yes, I do. I wrote some text in Czech for my students, which has like, I don't know, 200 pages. And in parallel, I recommend them all those Bibles we have in the operating system theory, which is the operating system concepts and modern operating systems. I just added a text written in Czech. And my experience is that after releasing this text, students are much better during the oral exams. Yeah, they are not just repeating the bullets they see in presentations. Okay, so many greetings to Jana. I'm really miss you all, and I would be happy to be with you. So, bye bye.